Getting started. This presentation is called Let's Get Technical, based on the Olivia Newton-John song, which everybody loves. I didn't choose it, but anyway, there it is. So we're going to try to talk technical stuff, and I've been given 4 different topics to cover, that being the conveyors and chain, the topper lift, the spiral, and the high-speed switch. And these are kind of going to go in order of less technical to more technical. So I'm going to go into great detail on most everything here, and I will do my best to keep it under the 15-minute mark, but I can almost tell you right now it's going to go over, just so be patient. This Zoom can take as long as we need to. I'm going to stay on afterwards for any questions, or if you want demonstrations of other equipment, I'm completely capable of doing that too. So, well, just let me know. So getting started, conveyors and chain. So we make conveyors. In case anybody doesn't know, I assume that you search for conveyors. You're probably here looking at our conveyors. You're probably very familiar with them. Conveyors get stuff from point A to point B. There's no science in that. It's what we do. We make conveyors out of modular chain, and some of the things that make our conveyors unique in the industry is we have the tightest turning radius of any modular chain conveyor out there. We all know who our competition is, but one of the things we do better than anything is we make tight turns. These 90-degree turns are just, based on the type of chain you use, nobody can make a tighter turn without a wheel bend. That's one of our significant, ways that we're better against the competition. The other thing that we have is just an absolute enormous amount of chain lengths. And of course, my thing is not working. Here we go. So this is a screenshot that I've taken of not all of our chain lengths. And at the current moment, we have just shy of, I think, 300 different lengths to choose from. This is just a small smattering of what we have, and they range in function and form and shape for just about any different kind of application you can imagine. We have, let me show you a picture of our chain department. It'll give you an idea about the vastness of how many links we use here. Here we go. Well, I had this working earlier, but it's not working now. There we go. So that's our chain department. As you can see along these walls here, this is all separate bays for chain links. And it's just an enormous amount of variety you can have. So one of the other things, talking about more technical things for the conveyors and chain, we do build it all here in Glasgow, Kentucky. We can mix and match chain links. Now, why is this not working? Had all this worked out prior. So you can see a little example of our the capabilities that we can have for making different types of chain conveyors. We can make cleated conveyors, ones with raised fingers, scoops, so we can handle bulk product in some cases. We have some special, unique solutions, which are very interesting. A new development that we have made recently is called pillow top chain. Sorry, this is so cumbersome. This is what it looks like. And I'll show you a SolidWorks model of this in just one second. So this is pillow top. And the unique thing about pillow top is it looks like a pillow from the side, right? Nice and bumpy, but the real nature of pillow top is what it does when it goes around our drive unit. And I don't know if it really becomes obvious, but what's really cool about this chain is that it forms a perfect cylindrical face as it goes around a drive, meaning that you can put a transfer knife right up against the edge of it like this. I'll just sketch it on the screen here. So we all know what a knife transfer plate looks like. We can literally, just shy of touching the chain, put it right there, and it's a perfect transfer. We've used this in many applications for transferring things like tortillas, very thin products. It'll transfer a beer coaster. I mean, it's pretty amazing what it does. So let's see. We also have the ability to twist our conveyors. Sorry, there we go. Let me clear my annotations here. And there we go. And I'm still annotating, sorry guys. All right, there we go. And so for pillow top, let's see, where was I at here? I was going to show you another model of some of the chain links that we have. Now we'll just move on here. So back to SolidWorks, we have different pitches of chain, 50 millimeter. There's pillow top. There's the 25 millimeter chain that we have. All different varieties, and these are all available on the website. We do accumulation. So we have accumulation chain, tube top roller, where you can have products roll across the top. And if you stop the products, you can hold it back with a very minimal amount of force. And of course, we all know what accumulation is all about. So some of the big advantages we have over our competition, of course, I did tell you about the tight turning radius. One of the other things that we also do is we coat all of our chain rods. And what that does is, I know a lot of you are probably familiar with what happens in the industry whenever you have a steel rubbing against UHMW or some other plastic. There's like a black soot that forms, and it's just nasty. Our chain does not do that, even though we have these chain rods rubbing against a plastic material all the time. And it's because of this process. So that's certainly something that we're very proud of, and it's definitely beneficial to anybody in the industry. We also, our chain is incredibly easy to disassemble. And I want a little animation here to show you what the disassembly process looks like. And excuse me for 1 second. So you can see right here, our chain clip is held, the chain rod is held in by a clip at the end. And literally just prying that clip out with a common screwdriver will allow you to pop that rod out. There's, of course, one on either side. So you can see how that works. So one big advantage over, belt systems is that, with a belt, you have to have the alligator type stitching or some sort of repair thing. And it takes a long time to repair a belt, or you have to replace the entire thing. With this, you can literally, if you somehow get damaged chain, it can literally change out whatever links are broken in a matter of minutes. It takes no time at all. So one last feature I'd like to talk about, and I don't know if I have a good example to show you, but I will show you the next thing coming up is the topper lift. Now, one thing about the drive unit, and try to disregard this piece, the chain actually looks like this section right here that's highlighted. One unique item about our conveyors is that we have no catenary. There's no place on the conveyor where the chain is let loose. And of course, I'm showing you the one exception to that right now, which is hysterical. But in basically every conveyor that we sell, there is no place you can actually, the chain doesn't droop down. There's no need to have a tensioning system. It's just something unique that we do that we've not seen in any other, in many of our competitors. Of course, now what I'm showing you now is the topper lift, which is our next section. Topper lift is a device that we make out of our conveyors. And this is a partial segment of the whole unit. Of course, this would have a drive and an idler at the end. Now, what's cool about the topper lift is that it's a way you can incline product much steeper than what normal incline conveyors can handle. Normal conveyor, plain plastic chain, no high friction, probably good up to about 5 degrees. A high friction conveyor, which we sell, uses a much more soft, sticky type of material. With that material, depending on the product, you're probably looking at maybe 30 degrees, okay? With the topper lift, you're easily able to do 60 degrees. Now that's very steep for any industry. You don't see that anywhere. To get above that, you're talking about some other special application like a wedge lift or some sort of spiral elevator to do that, or some sort of custom automation to lift your product up to some higher elevation. So obviously, the big advantage to this is it's very flexible. Whoops, excuse me, my Zoom is going crazy. So going back to the advantage of this, advantage to this, and I've got some more pictures I can show you. Big advantage is the different types of products that you can actually put inside the topper lift. Okay, and this is a topper lift in combination with a spiral. the topper lift will accept just about anything you can throw it inside it. There are some limitations, which I will go over here in just a second. But let me show you some other things. Let's see, topper lift, where are you? I had this so nice where I could just click and it would go to it. So here's a topper lift with bags, works very well with bags. Works great with boxes. And there's another photo here where we're showing totes. Topper lift works very well with very heavy products, actually. So yeah, I mean, we love this thing, and it's not expensive. I mean, let's be honest. It's literally like 2 conveyors compared to buying this versus some sort of piece of automation. I mean, it's not even a consideration. So this is a great solution, which we sell a lot of these and we love it. So very good solution. So I have a question in the chat. Do we have any live videos of the topper? Absolutely. Again, I think there are some on the webpage, which if I can get out of this, I can try to find for you. But let me wait till the end of the demo and I'll see if I can find some videos. But feel free to go to SpantecConveyors.com and look through the menu system there. And there should be one for topper lift. And I think it's under, I'm 99% sure it's under, well, it's somewhere in here. I'll find it later and I can show you some videos. But you can also find these on our YouTube page too. So we do have a YouTube page. I guarantee you'll find videos there. So wow, I've already gone on to 1 o'clock and I've only hit 2 of the topics. So anyway, really quickly, I'll briefly go over the 2 other items that I was hoping to talk about. The spiral is another solution that we have to help change elevations. The spiral is driven by what we call our outrunner technology, outrunner drive technology. And let me show you what that looks like. This is our outrunner drive, another drive unit that we use to push the conveyor chain along. This one works on the side of a conveyor, really good for single loop applications. But this technology is what's used on the spiral. So you can, we basically have this sprocket driving the side of the chain. It's a unique solution that we don't see much of in the industry, but we certainly have an application for it. There are all kinds of configurations you can have with the spiral. I'll show you a few of those. That's next. Give me 1 second while I bring that up. Well, I thought I had it. Maybe I don't. Okay, we'll skip that because the best one's coming up. Save the best for last, right? But to hopefully bring up some other examples of spirals to show you, you certainly do lots of tiers. We can have the entry and exit be in just about any configuration as long as it's divisible by the number of legs you have. So for this example, a 4-leg system would be you could do a straight through, a 90-degree exit, or a 180-degree exit, or even a 270. 6-tier spiral is going to have obviously the values of 60, 120, 180, that type of deal. I do have a SOLIDWORKS model to show you that, but again, I don't want to spend too much time, so I'm going to skip that for now because it's a rather large model. And I'm going to move on to the next section we have, which is probably the most technical product that we make right now as a standard product, and that would be our HighSpeed Switch. Now, if you've seen our HighSpeed Switch demo on YouTube, you've probably seen this guy. And it's unfortunate that what you see is this, because it's not high speed, right? So I'm going to bring up a video and I'll show you exactly what we're talking about when we say high speed. Give me 1 second. Let's see if I can find it. So hopefully it's not a blur for you guys. But this is a product test that we did using DVD cases. Hopefully you can hear me. I'll turn the volume down here. So this guy's running at about 450 feet a minute. Product rate is somewhere between 300 and 400 per minute. It's screaming right along. There's no doubt that it's fast. There's another view of it. So I'm trying to, tell you guys from an engineer standpoint some disadvantages. So the disadvantage that I have with a high-speed switch is it's sometimes hard to keep the product on top of the carriers. It switches so fast that things just want to keep going straight, right? There's another view here. You can kind of see that happening where, we really need some sort of high friction material on top, which we do have actually. So the high-speed switch is a very unique product for us. I'll show you. Let's see. Let me close everything here. And I'll show you what the actual model of the high-speed switch looks like. So we make this high-speed switch in several different flavors, and I can show you in 1 second some of the software we use, which you can get an idea of about the different types of switches that we make. Here we go. So what you're looking at in the background, this is a 1 to 2 high-speed switch, basically taking one lane of product in and sorting it from the right to the left. What I'm going to show you is our in-house estimator without the pricing, of course. But you can get an idea of about what's available for the high-speed switch, right? So what you're seeing here is actually what we call a 1 to 2 left. We do make these in several different varieties. We make the right-hand version. We make a 1 to 3 centered version. And then, of course, we make some larger units that are 1 to 4 left and right. And then we make some specialties that are 2 to 3, like a combiner, and 2 to 4, where you just have two. Basically, it's two 1 to 2s put together in the same unit. Okay, so we have all those. What I'm showing you right now is the 1 to 2, and it uses a carrier that has one toggle line. I'll get to that in a minute. But we also make the 1 to 3, which has 2 toggles on the bottom, and I'll explain why that is later too. But one thing about the switch that we make, and if you want to talk technical stuff, I don't know if any of you guys are familiar with how the competition's high-speed switches work. Most of them are based around the idea of having a solid pin on the bottom of their carriers, this guy right here. And then they have what I guess is more or less a gate to send that carrier through the right lane. If you know what I'm talking about, it's obvious, but if not, just suffice it to say that that little gate has to move very fast to get the carriers to go down the lane that they're supposed to go down. Ours doesn't have that restriction. What we do is we tell the toggle on the carrier which side to be on. And there's a huge advantage to that. And the advantage is this, and I will show you in just 1 second. So here's a model that I set up to show you how this thing actually works. And let me make this transparent. So what you're looking at here, this is the carrier, okay? It's coming through the actuator, which is kind of where the decision is made, whether this carrier is going to go left or right, okay? So this toggle can be in 2 positions, and it's only allowed to be in 2 positions, okay? It's kind of like a light switch. You push it on one side, it stays there. You push it on the other side, it stays there. So what happens is, if we want this guy to go straight, the toggle is at I'm going to call it the north side, okay? Let me just make this easy. We'll do it in this view. It makes it easier, right? So if we want to go straight, you can see that the toggle would be to the right side as it is now. This would be in the right position. I'm going to see if I can get it to go to the other side here, extended. Hopefully it won't blow up. There we go. So this is a basic cylinder, 2 positions, and then there are 2 ramps, okay? So this guy would essentially come through here, not even touch this ramp, and then go past the knife plate and just continue on straight, okay? We call this a knife plate because this is where it splits the flow. But what really happens is when you want to switch left, that's where the magic happens here. So let me show you what that looks like. And this actually I have worked up. So if we want to switch left, we come past the knife plate and it pushes the toggle to the left-hand side. Now here's the most important part about this. The most important part about this is this area from here to here, where absolutely nothing happens. All this is a time delay. And what this does is this allows you, it allows this toggle to decide what side it wants to be on. And remember that, because this is going to be really important later. So let's say the toggle has successfully switched over to the left. We continue down. We go to the knife plate zone, and we're now going off to the left. And that's how it works. Very simple. What's really important about this are the two things. You have this amount of time here, and don't forget that this toggle can only be in two positions. Therefore, by the time it gets to this knife plate, it will be on one side or the other of this knife plate, okay? Which means regardless of how you switch this, this is going to successfully pass the knife plate area. Now, because we don't have to worry about fancy timing down here, this thing is, it's virtually crash proof. And I know that's a pretty bold statement to make, but under normal operating conditions, there's no, even if you take this and actuate it by hand, which we have done 1,000 times, it does not matter about timing, how you want to make this work. One way or another, this guy's going to go either left or right. Now, the only thing that we require about this is when you put products on this system, they have to have a gap. There's a gap of 4 inches minimum between successive products to account for the rare chance that maybe this thing is in the middle position as it comes off of this ramp. And this guy doesn't really, there's some uncertainty which way it should go, left or right, okay? Now the 1 to 3 switch, hopefully is gonna open up. We'll show you how this guy works. And it's very similar. Hopefully it'll open up. There we go. Sorry about all the red arrows over here. Like I said, I've been throwing things together all day. 1 to 3 switch is very similar, but instead of 1, there's two toggles. Now I don't have a good demonstration to show you how this works, but basically the same theory applies. But as we come around this area, and I can show this. Oh my goodness. I can hear my buddies laughing in the next room. Okay. And sorry about the mess here. Like I said, I threw this together just for demonstration, but this is the important part right here. And I'll unhide, I'll transparent this. So the important thing here for this system, there's now a third element which comes into play, which is important. This is a reset plate, and the reset plate does nothing except for pushing both toggles to the inside. Okay, so regardless of where these toggles are, they will be on the inside. And if they're on the inside and nothing touches them, they will go straight through. So the middle lane is the default lane, okay? So if you want these to go left, let's say you want to go left. Well, what happens is this is a I don't even really know what the best way to describe this is, but the actuator here can run in, it has 2 different cylinders, and they can actuate separately, either retracted or extended. And this blue piece, if it's retracted, it pushes this wedge part over to the left. And I know I'm running out of time, but if you want me to demonstrate, I'll demonstrate it later. But what will happen is it will switch this toggle to the left, and just like the single, we'll send it down this lane to the left in this direction, okay? And same goes for the other one. This one goes over to the right if you want it to go right. If you want it to go straight, well, these two just don't even touch it and it bypasses, goes straight through. Now you might ask, well, what happens if both of them retract at the same time? Well, if that happened, you'd certainly have a problem, okay? But one of the requirements that we wanted to have with this was the same amount of crash proofiness, whatever you want to call it, as the 1 to 2. We didn't want to give it the opportunity to have that potential to try to spread apart and crash the system, okay? So what we came up with was a very simple solution. There's a bar in here, and this bar floats. And the length of this bar is just so that if either of these two retract at the same time for whatever reason, they will not retract far enough to cause a crash situation up here. They basically, you can see there's some distance here between this and this. If both of them retract at the same time, the worst that would happen is they would still just bypass, okay? It takes a full retraction for this to successfully actuate in one direction, just by using a piece of steel. So that's a high-speed switch. And you know, I've only taken a half an hour to do a 15-minute presentation. I hope you guys are still with me or haven't fallen asleep. But that's what I have. That's the technical stuff. Any questions? The only thing I have on here is the any live videos at the top. I'll tell you what, I'm pretty sure everything is set up to where if you want to unmute, feel free, and you can talk with the group, or if you're not comfortable doing that, feel free to just post it in chat, and I'll be more than happy to answer any questions I might have on the switch, the spiral, topper lift, or any other equipment that we make here.